All right, let's see. Ooh, that's right. So any questions from what we did last time, the integration by parts? Oh, sure, yeah. Homework problems. So 15?
The natural log of x. Integral.
Oh, yeah. So the first little thing is, if it was this, why would that be good? What could you do to that to make it easier to do stuff with? What property of logarithms helps you? The two can come down. You guys see the difference here, right? That's not the same thing. You can't do that. Because I'm squaring the whole natural log. I'm not just squaring the argument of the natural log. Right? So don't get too optimistic and pull that 2 out. Can't do that. So what do you do? And you're sitting there going, that's what I'm asking you for.
I made u the whole thing.
Okay, so if you make u the whole thing, then du would be,
Oh, du?
yeah?
2.
So the 2 ln of x to the first power times
1 over x.
the derivative inside, good old chain rule, right? dx. And then you let dv equal the only thing left, dx. All right, it sounds like it probably leads somewhere good. And again, if you let u equal ln of x, what mistake have you made?
There's another L.
What are you trying to use in that case? Use substitution, right? And if you're trying to do by parts, but you let u equal ln of x, what's still in your integral that dv has to be? If you let u equal a single ln of x, you still have another ln of x in there, don't you? Because you got 2 of those bad boys, right? So the biggest mistakes people make is they put u sub and by parts too much together. They think that they act like each other. They don't. I tried to make that point last time, right? The by parts, you have to be able to find all the parts in there. U sub, it can go wherever it wants to. It's a little bit freer, but not as many integrals work with U sub, unfortunately. We can kind of guess that since it's so easy, relatively. It probably won't be able to be used too much. Damn. Like Murphy's Law for math. So I'm going to let you guys go from there. If you didn't try that one, you can now have a kind of an idea where to go, right? Just to kind of go one more step. dv equals dx, so v equals x. So uv integral of v du. uv, just slap those things down there. Integral of v du. So what's kind of nice is the 1 over x and the x cancel, and then this will be, actually, this is an earlier problem, but you can do by parts again. That's the one we did by parts, the integral of ln x. I think we did that last time. X ln x minus x. Right?
Wait, what x is canceled?
Yeah, here, the x is canceled there. That's very nice. And then you just got the integral natural log, which is itself a by parts problem. Yeah. If you can't tell, I got something. Yay! Like, I've been so freaking sick this whole winter. It's weird. Again? All right, Jeff. Vitamin C. Yeah.
The 27. Yes. The inverse of cosine x.
Ew, gross.
Yeah, it's.
Now that's one. Does somebody have the? That's sort of like integral and natural log. And everybody's kind of thrown around on that because we might think it's 1 over x. But the only thing u could be is ln. That's exactly like this. What's the only thing u can be? Yeah. And it's one of the derivatives. You can look it up if you don't know it, right? So it's one derivative you should be able to do. So if you have u equals inverse cosine, what's du?
-1. It's -1 over the square root of 1 minus x squared.
Of course. I'll be honest with you, I don't have those inverse trig function derivatives memorized. I just didn't want to waste my time. I can kind of rederive them or just look at a table if I need to. So I'm not going to make you memorize them either. I'm never going to make you memorize anything I don't. That would be evil. And then dv, of course, has to be dx, the only thing left, so v is x. So uv minus the integral of v du. And what's really nice when you put the v and the du together, does somebody see what you can do with that interval? So you have uv minus the integral of v du, the minus and the negative become plus.
There's limits of integration.
Oh, and limits, sure. Blah, 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 blah. Who cares about limits? Just throw numbers in there, right? The hard part of this should be integrated. Throwing the numbers in, just don't forget to do it, but yeah. What's really, really nice about this? Why is it not going to be hard at all?
Just you can cancel it.
Is there a function inside something whose derivative is in there?
Yeah.
Yes, so you have an x squared thing, the derivative of that's about an x. Do you guys see how that should kind of jump out at you? You always look for u sub because it's relatively easy, right? And how do you know when to use u sub? When you have something stuck inside something whose derivative is free to move with the dx. I know it's not exactly its derivative. I don't care about numbers, do I? Just put the constants in there. Who cares, right? So I'll let you guys, can you go from there? I mean, if u is 1 minus x squared, du is negative 2x dx. So you have to put a negative 1/2 out here to get the negative 2 inside, right? So you end up with a negative 1/2 integral. This is du, and this inside is u. So the integral of u to the negative 1/2, that should be easy. Any power on a variable, that's an easy integral. Is that okay? Am I okay?
I got this far, but then the book changes the limits, it flips them, and that confused me.
Oh, sometimes the book flips the limits just because there's a minus on it. Because remember when you flip the limits, what happens to the integral? Change the sign.
So they just flip
Minuses
them
don't
to get rid
scare
of the
me,
negative?
right? Yeah, yeah.
Okay.
Or if you make the u sub, you gotta like change the limits, or you can do like I do, leave the limits alone and just come back to your original variable before you start plugging in. Right? Is that, we talked about that before. I put the limits in parentheses to remind me and whoever might be looking at my paper that those aren't the true limits for that variable. They'll come in later. Okay, maybe. Okay, so any other questions? Yeah.
Number 9.
In 7-1?
Yes.
Yeah, I guess so. It's the only thing we've done. It's like, Jeff, you haven't done much. Yeah, that's right. Put that up there for a second. It's better. No. 9. Let's see. And this one is really a variation on just integral of ln x. The interior is still just a linear, right? I mean, it should kind of work sort of the same way. What are you going to let u equal?
ln of 2x plus 1.
Exactly, ln of 2x plus 1. You have to. That's the only thing it can be. So du has to be 2.
2 over 2x.
I love it. 1 over 2 is 1 times the derivative of the inside, which is 2. Some of you guys some of you guys might know the derivative of ln is derivative of the inside over the inside. I don't know if you, right? It's just a shortcut to what the ln is going to do anyway. And then dv is dx, so v is x. And then throw all that stuff together and pray, right? Now what's going to happen though? This is interesting. What's going to happen? Let's take a look at this. Minus the integral of 2x over 2x plus 1. Right? Now that looks like it wants to be easy maybe. But could you use u sub on it? Yes, you could, believe it or not. So let me show you something that's kind of, and there's a few different ways to do it. The way that's a little more direct is if only there was a +1 here, right? If there was a +1 there, then it would just be 1. That would be awesome. Integrating 1's easy. So how can I legally just put a +1 there? As long as at the same time I -1, right? Right? Maybe. I'll show you a different way to do this. This is really, the math is the same really, but it's just using U sub, so you don't have to kind of like guess what's going on. This is going to be just 1, and both of those integrals are easy, right? What's the integral of 1? X. And what's the integral of 1 over 2x plus 1? Okay, ln of 2x plus 1 over 2, I love it. Right. Or you could do a U sub on that one if you needed to. Do you notice how 1 over x would be ln of x? 1 over 2x plus 1 would be ln of 2x plus 1, but that guy's derivative would have an extra 2 pop out, wouldn't it? So when I integrate, I need a 1/2 to kill that 2 that would pop out. That makes it quicker when you do this work. There's so many little linear functions you should not have to do U sub on. Right? It's just like when you integrate e to the 3x. What's that integral?
1/3.
Yeah, e to the 3x over 3. Because of the fact that when you take the derivative, a 3 would pop out. So you better divide by 3 to kill that guy because you don't want it there, right? That's all I'm doing here. Integral of that is natural log of that, but I want to kill the 2 that would pop out. Put a 1/2 in there, right? Yeah.
Could you do number 5?
Oh, wait, I want to show you the other way to do this. So if I'm right here, let's see. Right here. And this is related to, I think I've shown you this once before already, what you're allowed to do with U sub that you might not realize you were allowed to do. If I let U equal 2x plus 1, what's du? 2dx. And what's 2x? U minus 1, right? So now do I have everything covered in that integral? Hell yeah. So that's totally legal, no problem. You're just substituting, right? If one letter is a function of the other one, then you can rewrite it as a function of the first letter. Why not, right? So I get blah, blah, blah minus integral of u minus 1 over u. Did I remember everything? No. I left out by 2, right? How are we doing there? Do you guys see that? And why is this better? Because u over u is 1 minus 1 over u. Isn't that very similar to what we did here? We got a 1 minus 1 over the thing. Isn't that basically where we're going to get there? It's just, to me, I like the second way a little better because it kind of like just puts it all together for you. And because it's creative, I like that. But or you can just force that bad boy to work correctly here, right? Maybe. So this is the u minus 1. This is u. And I need 2 dx for du. That's why I needed a 1/2 out there to make my du, right? As long as I can find everything, I'm fine. So you can do a little more than you thought you could with u sub. Because it is just direct substitution. That should be easy. You should be able to do a lot with that. You can. Oh boy. How long is my voice going to hold out? Any other questions on that? Okay. All right, so today I'm going to try to do, definitely get 7.2 done and maybe get a little bit of a look at 7.3. So I've got a couple handouts related to both of those. But before I give you the handout, the problem people have with section 7.2 is they try to memorize everything. And I believe that there are certain things we should memorize, like what 7 times 8 is, which high schools seem to be not wanting to do anymore, which really makes my job harder. But once you get to a certain level, you want to memorize less and less. You want to just know a procedure to make it simple. If you like memorization, you got a lot of room up here, great. I don't have so much room up here, right?